The ocean covers 70% of the surface of the Earth. So we are really not planet Earth, we're planet ocean. Another effect of warming water, as I said, animals will move away, and we have tuna migrating to different parts of the ocean. And it's hard to explain how important the tuna are to the livelihoods of so many people and so many countries. Many island nations sell fishing rights for tuna in their waters as part, and it's a very important part of their gross national income. So right now, on average, the ocean in the last 50 or so, 60 years has lost 2% of its oxygen. But in some places, that number is 30% or 40%. One of the things I think is very important is that we elevate biodiversity loss to the same level that we think about climate change and realize that climate and biodiversity go together, and that biodiversity in the ocean has to be maintained, and the integrity of marine ecosystems have to be maintained if we want the ocean to continue to regulate climate and provide what I call carbon cycle services for the planet.
Did you know that ocean is Earth's silent climate hero? Covering 70% of the planet, it produces half our oxygen, absorbs 93% of excess heat, and shields us from the worst of climate change. But this lifeline is in crisis: warming, losing oxygen, and acidifying. Today, we are diving into why the ocean isn't just a victim of climate change, but a vital part of the solution. Joining me is Dr. Lisa Levin, Distinguished Professor Emerita at Scripps Institution of Oceanography and a pioneering deep sea scientist. For decades, her work has focused on climate change impacts in the deep ocean, from methane seeps to oxygen starved zones, and how human activities reshape these fragile ecosystems. A veteran of 50 plus ocean expeditions and 70 submersible dives, Dr. Levin co founded the Deep Ocean Stewardship Initiative to advocate for global ocean protection. She's also shaped critical climate policies, from IPCC reports to the BBNJ Treaty, ensuring science guides our fight for the ocean's future. In our conversation, we'll explore shifting tuna populations impacting vulnerable nations, the hidden crisis of ocean oxygen loss, and global efforts like the BBNJ Treaty to protect marine ecosystems. Dr. Levin reveals why saving marine life is inseparable from fighting climate change, and how global policies and everyday choices can still turn the tide. Thank you so much, Dr. Lisa, for joining me today for this conversation. It's a pleasure to have you here.
Thank you.
Dr. Lisa, can we first begin this conversation by first understanding the importance of oceans and why is it so important for us to focus on them from the point of view of climate change? Recently, I was reading this report in which I confronted that the oceans produce 70% of the oxygen, which I'm not sure many people know about. And there must be many other facts like that. Can we first begin this conversation by contextualizing the importance of oceans and then maybe delve into other issues?
Sure. The first thing I will say is that we actually don't have oceans on this planet. We have only one ocean. And it's something that people are increasingly recognizing, and it's very important in understanding its importance, because what we call oceans, the Atlantic, the Pacific, the Indian, they are all connected. It's one water body that's completely connected on this planet. And there's a really wonderful map that shows this from the top of the Earth. But anyway, the The ocean covers 70% of the surface of the Earth. So we are really not planet Earth, we're planet ocean. And that 70% number perhaps is where you heard 70%. But that's not how much oxygen the ocean produces. It's about 50%. And it is 50% over time. It's not like at any one moment the ocean produces 50% of the oxygen, but all the oxygen in the air, half of it came from the ocean. So it's, of course, very important in that regard. But the ocean does much more for us than produce oxygen. It absorbs heat out of the air. And it has absorbed 93% of the excess heat that we've produced from carbon dioxide emissions. And without that, this planet would be incredibly hotter, almost uninhabitable, which is why everyone, when we're looking for life on other planets, is always looking for oceans, because it keeps planet habitable for life as we know it. So that's one thing. And the other thing the ocean does in terms of climate is absorb carbon dioxide directly. And it's taken up somewhere between a third and a quarter of all the excess carbon dioxide that we've released into the air through our emissions on this planet. And so the carbon dioxide level would otherwise be much higher, and the planet would be much hotter as a result of that. There are many other things the ocean controls in terms of habitability of this planet. It controls the water cycle and how much rainfall we get and which areas experience drought and whether we have and how intense our hurricanes and cyclones and typhoons are. And then there's more related to sea level, which I can talk about later if you wish.
No.
So you asked me about the importance of ocean, right?
Yeah.
I mean, what I've talked about so far is the climate regulation property. But of course, the ocean feeds us, and I think it's something like 15% of the people on this planet rely primarily on seafood for their protein. The ocean provides livelihoods, not just for fishermen or fisher people, but also for other maritime industries, recreation and tourism and shipping and energy, and so on. Increasingly, it's also, we're looking to it for new pharmaceuticals and nutraceuticals and other industrial agents. And the marine life there is providing a lot of genetic novelty that's of use to people.
Dr. Lisa, as you've said that it's better to call it planet ocean, considering it's literally, like as you just said, it's one ocean that captures such broader area than the landmass that we have, and considering its benefit, like absorbing heat, absorbing CO2 for us. Like right now we here, like especially in India, we have started experiencing heat waves already, and oceans, especially who are absorbing so much heat, of course would be undergoing much more dramatic effects in them. I'm not particularly asking about heat waves in the ocean, but now where I want to pivot is to understand, like, this climate change phenomena that we are seeing. Obviously it would be having adverse effects in oceans as well. Can you a little bit touch on the aspect that how climate change is affecting oceans, and then maybe talk about what impacts is it having on it?
Sure. There are a lot of effects of those actions I just described. So by absorbing heat and carbon dioxide, the ocean itself is changing, and the chemistry of the ocean is changing. So as the air gets warmer, the ocean absorbs more heat, and that heat raises the temperature of seawater. And warmer seawater has many, many effects. I'll talk about a few of them, okay? Certainly, warmer seawater requires animals to raise their metabolic rate and respire faster. And many animals can't actually tolerate warm conditions, and they have to leave. And so they'll move to where it's not so warm. They might move deeper, but some animals can't tolerate warm conditions at all. Same with plants. The best example, probably the best known example, are the coral reefs, which cannot live at temperatures much above what they're already living at. And when the waters get too warm, they expel their symbiotic algae and turn white, and we call that coral bleaching. And it causes the corals to die. Sometimes they can recover if the water cools down the next year, but it's not good. And we have a lot of coral die-off on the planet. Another effect of warming water, as I said, animals will move away, and we have tuna migrating to different parts of the ocean. And it's hard to explain how important the tuna are to the livelihoods of so many people and so many countries. Many island nations sell fishing rights for tuna in their waters as part, and it's a very important part of their gross national income. But the tuna are moving east in the Pacific and out of exclusive economic zones and into international waters. So some countries will lose a very important part of income. And that's just a couple of examples of what warming can do. Many species are changing their distribution and moving poleward to try to find cooler waters. But warming also changes the solubility of gas in the ocean, and it turns out that warmer water can hold less oxygen. Warmer water is also more stratified, meaning that the density layers in the ocean are more intense, and that means there's less vertical mixing going on in the ocean, and those two things are causing oxygen loss in the ocean. We call that ocean deoxygenation, and that's something that I have studied quite a bit for the last decade or so. And when the oxygen declines in the ocean, in some parts of the ocean where it's already low and it gets lower, including these midwater layers where this oxygen loss is most intense, we experience species moving away, if they can move. They might move into shallower water where there's more oxygen, and they become more aggregated and more vulnerable to overfishing. So we see this in big fish like billfish, tuna, marlin, and swordfish, and we see this even in tuna. And so it's basically when the oxygen declines, it's effectively can be habitat loss in the ocean. Low oxygen is also associated with biodiversity loss, so many fewer species can tolerate low oxygen waters. So right now, on average, the ocean in the last 50 or so, 60 years has lost 2% of its oxygen, but in some places that number is 30% or 40%. For example, off of California, where I live. In moderately deep waters, like 200 to 300 meters, the oxygen has declined dramatically. So oxygen loss is actually a product of global warming and ocean warming. Again, as I said, as a result of changes in solubility of oxygen in the ocean and in changes in stratification and less mixing. Because normally oxygen in the air is very abundant and it's mixed into the waters at the surface, and it's mixed into the interior ocean, but the less vertical mixing there is, the more oxygen loss occurs in the middle of the ocean. And animals are always consuming oxygen, and decaying algae and so on are consuming oxygen. So normally it's replaced more, and that's happening less and less. The other thing that warming does is melt ice. And we have large glaciers and large areas like Greenland and Antarctica, which are having break off of icebergs and melting of ice, and that adds to the volume of water in the ocean. And then a warmer ocean has a bigger volume. It's just like an ice. If you compare the volume of water in an ice cube and then melt it, water takes up more space when it's not frozen. And so that's leading to sea level rise. And it's not uniform throughout the ocean. Different parts of the world have more intense sea level rise than other places, but it tends to inundate our coastlines and create flooding in cities, and it intensifies, and it makes the effects of storms and hurricanes and cyclones much more intense in our coastal areas. So sea level rise is not necessarily, helpful to us. So those are all different effects of warming, and there's one more that I'll mention, and that also comes from stratification. When the water's warmer, the density layers are more intense, and there's less vertical mixing from below of nutrient-rich water. So the surface waters receive less nutrients from upwelling, and they are less productive. And that lower productivity has trickle-down effects into our food chains, and also to the deep sea, which I study. So there's less food supply going into deep water. So there are big areas of the ocean that are starting to experience lower productivity from warming. So those are all follow-on effects of warming that come from our greenhouse gas emissions. There's also, I mentioned the absorption of CO2, and that leads to what we call ocean acidification, which is a lowering of the pH of the ocean, and changes in other what we call carbonate system parameters. So as the pH goes down, it becomes harder and harder for animals to calcify, make their skeletons, and that affects animals like corals that make big skeletal structures, or animals like bivalves, so clams and oysters and scallops, things that we like to eat. But lower pH in the ocean also has a big effect on the behavior of fish, for example, and probably on reproduction and other aspects. And people are, starting to study that. But the ocean pH has been going down as the ocean absorbs CO2. And while most of those changes happen at the surface, there's conveyor belt and thermohaline circulation that carries some of that warmer, low pH water down into deep water. So we're starting to see the interior of the ocean decline in pH as well.
Dr. Lisa, with all of the effects that we are witnessing and seeing, I'm not sure, but I read it somewhere that there's very less that we already know about deep sea as such. I read it somewhere that it's less than 10% that we understand about deep sea. I'm also wondering that sometimes we talk about tipping points, sometimes we talk about irreversible points from where it's very tough to come back. What do you think about oceans when we are talking about climate change? Are we looking at a situation wherein we are or close to beyond repair, or these systems can be worked upon still, and there is measurable progress that can be made with the kind of affairs that we are seeing right now?
Well, I would say that our insult to the ocean, it doesn't just come from climate change, right? So that's something to think about. I would guess your question is addressing climate, but and climate is a really important stressor. It's creating oxygen stress and temperature stress and pH stress on life in the ocean and processes in the ocean. However, we also are adding chemical pollutants into the ocean and plastics into the ocean. And we are overfishing some of the fish stocks in the ocean. And we have practices like bottom trawling that destroy and create a lot of habitat destruction and remove the three-dimensional structure in the ocean. And we're contemplating other activities like deep seabed mining. That hasn't happened yet, but that also would create significant stress. And even carbon dioxide removal with dumping into the ocean of that carbon also would add stress. So the ability of the ocean to tolerate the changes is going to be diminished by all these other human stressors that I've described. Now, we are far from extinguishing all life in the ocean, and honestly, this planet wouldn't survive if we extinguished all life, right? We need the phytoplankton and the zooplankton and the fish and the whales in there to have a healthy planet. I think that we have committed to some of this climate change for time to come, but that doesn't mean that we can't make it less bad, right? Less dangerous. And by reducing emissions, which is the main thing we need to do to stop greenhouse gas emissions and convert from fossil fuels to renewable energy, by doing that, we can slow the degradation of the ocean, and ultimately, the hope is that we can reverse it. We are not at a tipping point where we have total destruction or necessarily mass extinctions, but we are looking at a changing ocean. I mean, as we lose corals, it's not clear that all coral species will recover. We know there are some that are more tolerant to warm water, and there is the potential for some organisms to adapt. But I don't think we necessarily will have the ocean that we had 200 years ago anytime soon, if that makes sense.
No, absolutely. And Dr. Lisa, without trying to oversimplify this complex interplay of systems that operate, what according to you would be the biggest stress, as you mentioned, that it's not only climate, that there are other aspects as well, that these human stressors that we see. What according to you would be the most significant stressor that our oceans are dealing with today, if I'm not trying to oversimplify things?
Wow, that's hard. I don't know if I'm even qualified to compare all these stressors. Honestly, in my mind, climate change is the biggest threat to the entire planet, and that probably also applies to the ocean.
Yeah.
But there's a lot of others, and I think one of the things I think is very important is that we elevate biodiversity loss to the same level that we think about climate change, and realize that climate and biodiversity go together, and that biodiversity in the ocean has to be maintained, and the integrity of marine ecosystems have to be maintained if we want the ocean to continue to regulate climate and provide what I call carbon cycle services for the planet. And for that to happen, we have to put all the tools we have in our toolkit to use to maintain biodiversity in addition to addressing climate change. And I think we need to address those two crises together.
And Dr. Lisa, like while understanding all the issues that today oceans face and how things are moving forward, are there any particular strategies or things that you think hold promise, especially some of the solutions that we are working on, which can help to either one mitigate or adapt with this changing climate that we're talking about?
Well, we need to do three things. We need to mitigate, and we need to adapt, and we need to add a third thing, which I call carbon conservation. We need to recognize that conserving the functions and services that we have and the carbon cycle that exists now is not mitigation, and it's not considered adaptation in the policy world either. And so I would say we need to elevate all three of those things and adjust our current practices. And we can be climate smart in everything we do. There isn't any human activity that couldn't benefit from looking at it and seeing whether it can be adjusted, adapted, modified to help address climate change, but also to conserve that biodiversity that provides all those climate services and carbon cycle services that I've been talking about. I forget if I actually answered your question.
Yeah, I mean, I was also just hoping maybe to understand from you an intervention that is maybe taking place right now for ocean conservation. We recently saw the passing of BBNJ Treaty, which basically protects ocean beyond the national borders. What I'm trying to understand is that is there a strategy, an invention, or a treaty about which you are most optimistic about and you think holds the promise towards ocean conservation?
Well, I think the BBNJ agreement that you mentioned, which hasn't gone into force yet because it hasn't been ratified by the 60 countries, but hopefully that will happen soon, offers tremendous potential because it covers all the international waters, which is 60% of the ocean. If we want to be able to conserve the ocean and its health, we need to take care of that 60%, of which almost all of it's deep ocean, actually, at least 96%, I think. So that agreement offers the potential for the creation of protected areas. And while we can't solve climate change with protected areas, we can certainly help the resilience of marine ecosystems by protecting them from some of these other types of insults that I was talking about. So protected areas are critical. I know that the Convention on Biological Diversity has a framework with a goal of protecting 30% of the planet by 2030. And in order to do that, we have to protect international waters as well. So BBNJ would be a big step towards allowing us to do that. It also has provisions for environmental impact assessment, and we have the potential to apply climate criteria in looking at activities and how will they, beyond greenhouse gas emissions, would they harm ecosystems and the abilities of those ecosystems to fix and sequester carbon, for example, which is important to climate change. So there are benefit sharing for marine genetic resources. That's part of the BBNJ agreement. And potentially those genetic resources might hold some climate solutions for us. They could help. And then a very important part of this agreement is the capacity development and technology transfer components. And because really protecting our ocean has to be an endeavor that's carried out by every single country on the planet, especially the ones with with coastlines along the ocean. We have to help make that happen. In other words, not all countries have the expertise, the instrumentation, the knowledge. Many have it, but they don't have the money to put it in place. So there's a lot of things that could help with that in the BBNJ agreement. I think it's a really important agreement, but it's not alone going to solve climate change. And in fact, there's only minimal language about climate in the agreement. I definitely was present at the very last negotiation meeting for that agreement and helped work with several people, including the G77 in China, to get some important language in that negotiation text that acknowledges the link between biodiversity and carbon cycling and climate regulation. So that's in there, one little phrase. But we really need the UNFCCC, which is our, the UN Framework Convention on Climate Change, to come to an agreement and to phase out and get rid of fossil fuels. That has to happen if we want to address climate change. I cannot see us solving the climate problem any other way, but it's been increasingly difficult to make progress on that front.
Dr. Lisa, would you want to take, because you would talk, like your example about each country needs to take the accountability with respect to its actions for basically protecting oceans too. Would you want to take an example or maybe share a case in hand wherein a country as such would have implemented a particular example or something that stands out for you wherein an initiative is taking place in one part of the world?
I would say a good example can be found among the small island developing states. They are intimately connected to the ocean in many, many ways, culturally, spiritually. They're economically really close connections. They experience the brunt of climate change, typhoons and storms and hurricanes and so on really decimate small island nations, especially in the Pacific, but pretty much everywhere. And they have recognized the importance of addressing climate change, even though they didn't cause it, right? And so they become very vocal at the UNFCCC COPs, the climate negotiations. They have practices that themselves can help, within their nationally determined contributions. For example, restoring coastal wetlands, which are important climate sinks, seagrass beds, and so on. And generally having practices that reduce emissions, but they don't cause most of the emissions. But I give them a lot of credit for uniting countries and leading efforts to address climate change globally.
Thank you so much for sharing all these insights, Dr. Lisa. Before we wrap up this call, would there be one call to action which you might want to share for different stakeholders, considering the vastness and complexity of the ocean itself? I'm assuming that there could be different call to action for different stakeholders, but if there would be one that you might want to share.
Wow. Because of the country I live in right now and the current situation where climate change is pretty much being erased everywhere it can be, I would say my call to action is for people to not give up, to recognize the importance of addressing climate and the importance for the whole planet, and to realize that they can both personally act in a way that's responsible and releases the least carbon dioxide possible, but they can also elect representatives at whatever level, city, state, federal, that will help, that believe that this is an important problem and will devote resources to addressing it. So voting is one thing that people can do to help address this issue.
Thank you so much, Dr. Lisa, for taking out time for this conversation and highlighting some of the critical aspects which I deserve a lot more attention than what it is being given to right now. And considering, as you've explained, like the imminence of this issue, it all the more becomes important that we give the due time and effort in solving this issue as well. So thank you so much for your time, and I'm grateful for sharing all your insights. Thank you so much.
Okay, well, thank you for holding the podcast and helping us address the problems.
Thank you.